going to go over the worksheet that you would have received on Monday called the Additional Review Chapter 6 Test. There are additional copies if you would like one. So remember, this is an open notes test, so go ahead and take down any notes you'd like on this that you think might help you along. So on this form, you'll also notice that it's got a lot of questions like the test, but I did leave out the first part, which if you look at your chapter, let's see, I'm looking for another sheet here. So let's just show you this here. If you look at your one of the reviews, this is the B review, I don't have more questions like these. So just kind of remember on those, some of the highlights, anything to the 0 power is 1. On this type of problem, if you have two bases that are the same, make sure you add the exponents together. Don't leave a negative exponent. That means you have to flip the fraction, and I would take either one of these as the correct answer. And then on these two, they're very similar. If you have a negative exponent, you flip that fraction again. Since there's a 1 on the bottom, you can basically ignore it. And then the exponent applies to both of the terms on the inside here. So it's 3 squared, which is 9, and then x squared squared. So in this case, you multiply those exponents. On this one, the 3 applies to both, so negative 3 times itself 3 times is negative 27, and multiply those exponents. The other part that I don't have on this review that I'm going over now is what I call the calculator section. So just remember, you can put in these right into a calculator and just replace the x with that number. And it doesn't matter if it's f of x or y. Just put in what you see on the right and plug in that number. All right. So back to the sheet that you would have received Monday. The first two, they're like questions 5 and 6 on the reviews. So it's good to have an idea of what the basics are here. So you do need to write down what the first term is on your recursive rule. And then you have to say, how are you getting to the next term? So that would be r times a and then sub n minus 1. Above explicit rule, you're going to have a sub n is equal to the first term times r to the n minus 1. So we just need to figure out what the first term is and what the r is, and we can plug things in. So first, to get the r, which is what this is right here, that's what you're finding, the common ratio, you need to just take a look at a couple of the terms. I like to look at the first two. So you ask yourself, 3 times what is 6? It will be 2. But in case you can't see that, you take the second number and divide the first number, and you get your common ratio, which is a 3. And I'll put a box around it. So we now have the r part. Notice for the recursive rule, it says I have to go ahead and identify what the a1 is, but that's this number right there. So that is my a1, my first number, which is a 3. So I can just write my answer. The first term is a 3, comma, and then to move on, I have to multiply it times 3. And I just realized I've made a little bit of a mistake, but I don't have time to redo this here. So I was supposed to divide that by 3. That was supposed to be a 2, and this will be a 2. So my bad, but I don't have time to redo this, so I'm going to just go with it here. So we are going to put the r right here, which is a 2 times a sub n minus 1. Okay? Glad I caught that, but I remember they weren't both the same number, so anyway, let's move on. So I have my a sub n is equal to my first term, which was the 3 times the r, which we now know is a 2, and then we have n minus 1. Okay, now for the 9th term, I'm just going to plug in n is equal to 9 into this equation. So a sub 9, so the 9th term is 3 times 2 to the 9 minus 1. Put that into the calculator, and you'll get 768. Okay? Sorry again about this. Hopefully you didn't stop because you were wondering what the heck I was doing, but it should be 6 divided by 3 is 2. All right, we're going to do the same thing for the next one, and I'm just going to highlight this area up here because I'm going to use these again for number 2. So the common ratio, now this is going to be a rather large thing to do here because you have to do 16384 divided by 65536. That is going to equal 0.25. Now I know some of you might look at this and realize, hey, aren't we just dividing by 4? And you are. So you could write R as 0.25 or 1 over 4. So remember, if you're dividing, it's not R equals 4, it's the reciprocal of what that number is. All right, so recursive rule, just kind of doing this again. So my first term was that big number, 65536. And then I have to say how I get to my next term, which will be, I'm going to use the fraction, just so it makes it a little shorter there, times a sub n minus 1. So you can put in the decimal or the fraction. For the explicit rule, I need to put in the first term, which once again, 65536, and then 1/4 n minus 1. Okay? And then ninth term, once again, n is equal to 9 in this case. It's not always going to be 9, so make sure you look at what they're asking for. So a sub 9 is equal to 65536, and then I'm going to have 1/4 to the 9 minus 1. And if you put that in, it might be a little surprising, but the answer is going to be 1. Now on both of these, you could also get this last answer by just continuing this pattern. 256 divided by 4 would be 64. Divide that by 4, you get 16. Divide that by 4, you get 4, and then a 1. So this would be the ninth term, and that shows you that that's correct. And you could do the same thing up here. We're multiplying by 2, so just multiply by 2 4 times, and you'll get 768. All right, in this next section, I'll slide it right there. Determine whether the sequence is exponential growth, exponential decay, or neither of those. And then it says to show why. So on this first one, notice it's 2, 4, 6, 8. That is a sequence, but it happens to be arithmetic. We are adding. And in fact, we're adding 2 on that one. But exponential growth will be multiplying by the same number. And then exponential decay, most people think of that as dividing. Okay? Technically, it could be multiplying or dividing as long as you're multiplying by a fraction. But, you know, we normally in class, we refer to this as multiplying and that's dividing. Okay? So this is neither of those. So, yes, it's arithmetic, but that's not one of our choices. So this one is neither. On this one, you might notice that we're going down. So we're dividing by 5, but that's that thing with the dividing up here again. So divided by 4, r was 1 over 4. So down here, if we're dividing by 5, r is going to be 1 over 5. And so that would be an example of exponential. I'm just going to put exp, and then we're dividing, so that's going to be going down. That's decay. Over here, we're multiplying by 2. So that would be an example, since we're getting bigger, of exponential growth. And the r this time is 2. You don't have to flip that since we are multiplying. Okay, I'm going to move down a little bit more. And on this next one, 6, 7, and 8, we do have the option of arithmetic. So just kind of remind you here, arithmetic would be adding or subtracting the same number. Geometric would be multiplying or dividing the same number. And then we have a neither. It does say that we have to state the common difference or ratio if there is one. So on number 6, hopefully you notice that they're all adding 3. Since it's adding, that tells us that it's arithmetic. And then this part right there, that's going to be your common difference. They're all 3 apart from each other. On this next one, we are dividing by 2. Since it's dividing, that's geometric. And it's an R. Now it's not 2, it's 1 over 2. And you will lose a little bit of points if you tell me R is 2, because that would be saying it's getting bigger. But it's getting smaller from left to right, so you have to flip that. Over here, this is actually going to be a neither. You might think, oh, aren't we multiplying by 2? But this is times 2, so is that. But 20 times 2 is 40. So this is actually like 1.5. Okay, so they're not the same right there. Okay, so you could just write neither. And the last part on this review, we have to identify if it's growth or decay, and you really just have to look for what's inside the number inside the parentheses. Okay, so you're going to have in all of them f of x is equal to some number. I'll just call it a, and then let's just call this 1 plus r to the x. But basically, it's this right here. Okay, we just have to look at this. If that number is more than 1, so more than 1, it's growth. And if it's less than 1, it's called decay. All right? So over here, I'm just going to highlight, we're just looking at what's inside the parentheses. I also sometimes call that the base. So 1/3, that's equal to 0.33. That is less than 1. So this would be an example of exponential decay. I'll go ahead and write EXP right there, exponential decay. And then the y part, you could just say 1/3 is less than 1. I'll use the symbol there. Okay? Over here, 1.5 is bigger than 1, so that would be exponential growth. And you can say 1.5 is greater than 1. That's good enough. And then over here, 4/3, if you do that into the calculator, that's 1.33. So that would be another example of growth, so exponential growth. And then the reason 4/3 is bigger than 1.